Nikos Kexagias, where is he? Did I pronounce it right?
Yes.
Oh, thank God. Wonderful. CEO from, Entschuldigung, sorry, Nanotypos, and he gives us more after this.
Yes. Okay, thank you very much from my side. Very briefly, who we are, what we do, what problem we have, how it is being solved within the Appolo project, and some results and some numbers to show this impact. So in a big picture, we are a small SME company, quite brave, I would say, because we are located in Thessaloniki, Greece. So we only have 4 years which we were established. What we do is imprint-based nanomanufacturing. So we use a mold to imprint or to replicate micro or nanoscale features in different materials. And the big picture is that by creating micro or nanostructures on surfaces, we can enable added value products and intelligent functionalities. Which one of these functionalities we'll see later on. So our business units, we are focused on 4 business units. We do roll-to-roll imprint lithography to create large area nanostructured surfaces on plastic films. We have a lot of work on holograms or security or product authentication solutions. We're looking a lot into biomimicking surfaces, and of course we provide services for in general nanofabrication services. So the manufacturing technology which we basically use is this UV, ultraviolet light assisted nanoimprint lithography, where we have our substrate, we dispense a monomer, a UV curable monomer. We have our mold with the targeted structures or devices. We print the mold, we bring in contact the mold with our UV based imprint. Just a few seconds is enough. We flush UV light from the back side or from the substrate. Either way, one of the two would have to be transparent for the UV light to cure the monomer, and then we just separate and get this negative replication of whatever we have on the mold. This is an alternative nanofabrication technology. It is being positioned into the industry, so I could say that most of the companies which are manufacturing LED are using nanoimprint lithography to extract or enhance the efficiency of the light extraction of the LEDs. The resolution limit here is about 2 nanometers, so anything which is placed on the mold will be definitely replicated in the curable resist. The other beauty of this technology is that it's a one-to-one process, so we're not using beams, so we do not influence the properties of this polymer. You can think of 3D topographies. These will efficiently be replicated in the monomer. So the evolution of the planar or batch process is the roll-to-roll based imprint lithography. And the main difference is that our mold is a cylindrical mold, where we have structured, placed on a drum, and in a meter-to-meter production scale, we are just producing tens of meters of functionalized films. So this is basically the technology, the manufacturing technology which we're using. These are photonic crystal structures. These are pillars of 500 nanometers, about 700 nanometers in height, and are produced in a meter-to-meter basis. Now you can see here that we are limited, that we can use only batch because we start from the silicon processing. So we are limited on maybe 200 millimeter wafers, and this creates this, let's say, shims or the defects. So it's not a continuous pattern. And that was the main technology, or that is the main bottleneck that we have in this roll-to-roll manufacturing process. So what the current industry is doing now, we're using small dies. These are generally fabricated by E-beam lithography, which costs a lot. So you cannot go do E-beam lithography on tens of centimeters. So what one does is just create a little die and then step and repeats this over larger areas. But even no matter how precise the stepping is, you'll always be getting a defect. So this is the main bottleneck which we're facing. Apart from the optical defects, the cost of generating such large area structured surfaces is very high. So there's very few companies in the world that can do this, and the cost is more than 20,000 euros for a large shim like that. Nevertheless, even if you get this shim, you always have to bend it around your mold. So you will be creating this extra shim even if you do laser welding. So that's the other bottleneck. So even if we have this shim and we curve it around our cylindrical drum, we will always be getting this shim. So within the Appolo project, we thought that having access to laser, high picosecond laser technologies, we can do directly the milling, let's say, directly on the drum. So we have a shim with no, we have a sleeve, sorry, with no shim, and we do the laser lithography of our targeted structures. So this is what Appolo has been helping us in. So we have access to our colleagues in IOM, which have these laser facilities that can be doing dual if needed. They have two wavelength systems within the same machine, and they can be structuring directly on the drum or on the sleeve of our mold. So today we have managed to produce such hydrophobic or super hydrophobic films. So this is the mold. So the laser, with the laser we are drilling holes. These are micro scale holes. It's sufficient enough for our application. We want to create super hydrophobic surfaces over large areas, targeting different applications. And this is the imprint of how these negative pillars have been replicated from our molds. Now, this is not perfect, we're still working on it, but we are achieving a water contact angle of 160 degrees, which does make our surfaces super hydrophobic. Now, the opportunities that Appolo project gave us is, of course, the assessment of state-of-the-art equipment and processes. But for me, it's not that important. As important is to have highly educated and highly trained personnel using those machines. So it's not the machine which will give us the result. It is the person behind the machine who has the knowledge and skills to push the limits of the processes. Of course, having the complete manufacturing chain within a project like this one is very important. So we have the collaborators that produce the sleeves. So one collaborator produces the sleeve, the other one does the texture, the structuring, and we do the replication over meters. So this is a very short, let's say, manufacturing chain that we have. This solution provides us to offer turnkey solutions to our customers, customized in a very short delivery time. We could do large area functional surfaces and has opened very much new business opportunities. Just some numbers. We were pretty much nothing back in 2014, and we have a very good successful growth rate projected for 2016. We have disseminated our results in international and national conferences. We have, very importantly, one student being trained in these technologies. And of course, we have increased our budget, and also we're looking forward to hire one more additional person in our company. So in terms of cost saving, the impact we can deliver in less than 1 week, the targeted material. We are using less material in the overall process. Only 2 steps are needed, so we do the laser structure and then the embossing. It's a greener technology, so we are not using any kind of chemicals to create these added functionalities on our plastic surfaces. And of course, it's a much, much cheaper technology, assessment technology, than rather doing UV lithography or even, of course, E-beam lithography. So this was the end of my talk. Thank you very much.